Good evening, friend. It's nice to share this quiet with you. In the hush of the room, your shoulders soften on their own, and your breath drifts like a small tide. You're safe now, nothing urgent, nothing loud, only a quiet room, a soft voice, and the steady rhythm of your own breath. Tonight, we tuck a small, shimmering question under the pillow. Will humans ever drift beyond the sun's warm lantern and truly leave the solar system? We won't hurry it. We'll move slowly, like starlight crossing a window, following calm paths from familiar planets to the dim edge where the sun's influence fades and interstellar night begins. Along the way, we'll listen for the faint messages from distant probes and imagine how a future crew might cross that border with patience, courage, and a good night's rest. If this gentle journey brings you ease, a quiet like and a soft subscribe. Help others find this haven too. No rush, only when it feels right. For now, let your breath lengthen, your mind grow lighter, and your thoughts float like dust in a sunbeam. Close your eyes, the stars are waiting, and we'll begin together, unhurried and warm. Night itself was our first observatory. Long before lenses and engines, people looked up from firesides and doorways and traced meaning on the sky, the way a fingertip sketches on a fogged window. Hunters and goddesses, cranes and dragons, boats and bear stories stitched constellations into a map the heart could follow. Along the Nile, bright stars seemed to speak to stone. In China, careful watchers folded sky into calendars. Across the Americas and the Fertile Crescent, priests and farmers read the seasons from the patient glitter of heaven. The points of light were not decorations, they were order and omen, compass and comfort. Under the stories, curiosity breathed. Perhaps those pinpricks were other suns. Perhaps worlds circled them, quiet as seeds beneath snow. A thinker like Epicurus let the thought unfurl. If one world, why not many? If life here, why not elsewhere? The idea drifted gently through centuries, gathering patience rather than proof, refusing to go out. It still glows in us, the feeling that the universe may be a garden with many gates, and we have only just stepped onto the path. This urge to cross distance is stitched into us like a soft refrain. Horizons don't forbid, they invite. Ancestors left valleys and walked toward coasts they could not see, then learned the weather of open water and the grammar of stars. They followed rivers through mountains, read winds across deserts, carried songs from one night fire to the next. Maps widened and home deepened. The same thread now tugs upward. Coasts have been met, peaks named, the earth cherished and known in its limits. Still the eye lifts. Awe does its steady work. Under a winter sky, a person can feel small and fortunate at once, as if admitted to a quiet theater of immeasurable scale. The stars ask nothing and give calm. In that hush, thoughts slip between suns with no weight at all, turning distance into a kind of music. The mind travels where the feet cannot, and the heart follows, unhurried. Survival speaks in a low tone beside wonder. The earth is generous and precarious. The fossil record remembers endings. Fire and ice and impact have rewritten chapters of life more than once. Planting seeds in more than one field is an old wisdom. Reaching other worlds is not a boast. It is careful housekeeping for a species that hopes to endure. A second hearth does not dim the first. It keeps the flames safe. Adventure sits near survival like a companion star. People test themselves not to suffer, but to feel courage warm in the hand. The unknown sharpens attention. Skill grows where risk is real. Space keeps the oldest promise of challenge. Emptiness to be turned into passage. Danger into craft. Loneliness into community. For some spirits, the thought of a red sunrise over a Martian plain or pale light across an ice moon is a quiet brightening that refuses to fade. Telescopes added detail to wonder without ever closing it. Galileo watched little lights circle Jupiter and heard a clear message: we are not the center. Hubble and, later, the James Webb gathered galaxies like distant lanterns, showed newborn stars wrapped in dust, and measured the stretched whispers of ancient light. Planets proved common, some placed in soft gold zones where water might linger and chemistry might sing. Each discovery widened the margins of the page and made room for more careful dreaming. Action followed yearning. A human Yuri Gagarin rode a small shell of metal and faith around the Earth and returned with a smile that looked larger than gravity. Boot prints pressed into lunar dust said, in a new language of quiet, that a door could open and stay open. The moon is a neighbor across a dark street, yet visiting a neighbor changes what a neighborhood means. Millions watched, not to conquer anything, but to share the way distance briefly yielded to reach. The sky also touches places measurement can't quite hold. It invites questions, murmured since first breath. Who are we? Why are we able to ask? What lies within and beyond? For some, the stars arch like a cathedral roof. For others, they shine like a laboratory ceiling under which law and pattern can be learned. Both views ask for care and gratitude. Reaching outward becomes a path inward, and the long look into the deep often returns us gently home. If we go, we won't go empty-handed. Language will travel lullabies and jokes, recipes and proverbs. Art will travel poems clipped to a bulkhead, a sketch taped above a bunk. Science will travel careful instruments, practiced hands, the habit of writing down what happens and what might. A cabin light on a ship bound for Mars will fall across coffee, a photo, and a checklist, all of it human as rain on a porch. Warmth in cold places has always been our craft. The longing is personal as well as planetary. Children tilt their faces to the first star and make a wish. Writers stack whole civilizations between two covers and send them to suns with singing names. Filmmakers slow time until bodies float and voices sound like close thunder. Even those who will never leave Earth feel steadied by the thought that something we built, Voyager, for instance, has sailed past the last weather of the sun into the level tide of interstellar space, carrying a golden memory of who we are. The road outward is long and not offended by slowness. Distances pile like blue mountains layered on a clear day. With tools we have now, reaching the nearest star would take longer than names can hold, journeys counted in generations, not years. Hazards gather, radiation like steady rain, cold that feels like a kind of dark silence that must be answered with ritual and song. These are not scoldings of the dream. They are its teachers. Challenges make longing honest. Imagination goes first, then patience, then the small, repeatable work of turning far into near. From above the weather, astronauts speak of a soft shock with a tender name, the overview effect. Borders fall quiet, cities blur into lace, and the planet shows itself as it is solitary and astonishing, wrapped in a thin, living blue. Seen that way, leaving is not abandonment. It is a way of carrying home more carefully, of holding its image like a talisman, in places where no tree has ever shaken in wind. The farther we look, the more we understand the rarity of a world where water sings against shore and breath arrives on its own. Beyond the Kuiper Belt and the sun's last confident push, the galaxy waits without hurry. The pool of other stars is faint but certain, like music from another room late at night. Whether our instruments cross first or our bodies follow later, the gesture is the same, an open hand extended into a darkness that is not empty, only undiscovered. In the stillness between heartbeats, the thought of leaving the solar system softens from a shout into a promise to travel kindly, to learn carefully, and to keep the light of home bright enough to find when we turn to look back. Far beyond the slow blue of Neptune, distance turns into a soft kind of weather, thin light, long pauses, and roads that stretch for ages. The numbers are heavy on paper, yet they can be held lightly, like a smooth stone turning warm in the hand. One Earth-Sun span, the quiet yardstick called an astronomical unit, is about 150 million kilometers. That first step is already a continent of space, and still it is only the beginning of the solar system's long, unhurried breath. Every world keeps time in its own circle. Mercury loops through a year in about 88 Earth days, a bright moth close to the flame. Venus takes roughly 225. Earth carries us through 365, the cadence we live by. Mars stretches the note to 687 days. Beyond the frost line, the measures grow spacious. Jupiter needs nearly 12 Earth years, Saturn about 29, Uranus 84. Neptune, a stately 165. The farther you go, the longer the music holds each note. Space between neighbors opens like wide water. Jupiter circles a little over 5 astronomical units from the Sun, Saturn around 9.5, Uranus near 19, Neptune about 30. Past that blue frontier, the Kuiper Belt spreads like a dim garden, from roughly 30 to 50 units, not crowded with noise, but with patience. Icy bodies moving on paths that take decades or centuries to repeat. The figures may feel abstract, but they simply say this: the lanes are generous and traffic is sparse. Against such gulfs, the planets themselves are small, magnificent in weather and geology, yet modest beside the emptiness that carries them. Earth is a bright bead roughly 12,740 kilometers across. Jupiter, swollen with storms, is more than 10 Earths wide. Saturn, a little smaller. Uranus and Neptune, wider than Earth, but shy beside the giants. Even so, each is a speck when set against the billions of kilometers of near vacuum it must cross to complete a single lap. Moons keep their own small neighborhoods. Our moon sits about 384,000 kilometers away, a distance you can feel on a night when its light lays a pale path across the floor. Around Jupiter and Saturn, the numbers swell. Ganymede orbits at roughly 1,070,000 kilometers, Titan near 1,220,000. These are intimate archipelagos, pockets of gravity where tides, resonances, and long companionship write gentle patterns in ice and rock. The Sun, generous and commanding, still seems humble before the breadth it rules. Its face spans more than 1,000,000 kilometers, yet its pull must reach billions to guide the planets, comets, and dust. Far outward, that grip relaxes from command to suggestion. A boundary with no signpost, the heliopause marks where the solar wind yields to the wind of the galaxy. Beyond, interstellar space begins like a deeper hush, and the Sun becomes one bright star among many. Between Mars and Jupiter lies a faint ring of leftovers, the asteroid belt, a memory of building that never quite finished. Most pieces are small as houses or hills. A few, like Ceres, nearly 1,000 kilometers wide, are rounded by their own gravity. The belt spans hundreds of millions of kilometers, yet is emptier than many imagine. You could fly through without seeing a single rock, though all of them move fast, tens of kilometers each second, quiet proof that even in stillness, motion rules. Comets write long, pale sentences across the dark. Many begin in the Kuiper Belt, or in the imagined shell of the Oort cloud, a far realm that may extend tens of thousands of astronomical units in every direction. They sleep in that cold until a nudge changes the geometry. Then they fall inward on stretched ellipses, gathering speed as sunlight sharpens their tails. Halley's Comet keeps a human cadence about 76 years between bright visits, while others count in centuries or millennia, one long orbit that begins in darkness and returns to it only after lifetimes. Even light tells you how large our neighborhood is. Sunlight needs a little more than 8 minutes to reach Earth, to Jupiter about 43, to Neptune roughly 4 hours. In a realm where the fastest thing we know measures travel in minutes and hours, human engines must learn patience. Missions to Mars ask for 6 to 9 months, to Jupiter often 6 years, to Neptune more than a decade. Trajectories become conversations, with gravity borrowing speed in a slingshot here, returning it there until a careful thread of motion is woven through the quiet. We have sent small emissaries to test the edges. Voyager 1 and Voyager 2 slipped past the giant planets long ago and kept going, their tiny hearts still warm in the cold. Decades on, they crossed the sun's weather and entered the larger sea, more than 20 billion kilometers from home and counting, their voices faint but faithful. They carry maps and music and the kindness of a message that begins, "We were here and we were curious." Most of the solar system is emptiness that acts like architecture. The void is the stage where gravity arranges its ballet, wide lanes for planets to keep steady time, quiet corridors for comets to glide and return, resonant pockets where moons hum in synchrony. The space between is not absence, but permission, room for motion to remain graceful for eons. Farther out, beyond Neptune's orderly file, trans-Neptunian worlds make their slow circuits. Eris, Haumea, Makemake, and others glint with distant sun, their years stretched long, their surfaces carved by cold. Some rare wanderers, like the enigmatic Sedna, travel so far that a single stroll around the sun lasts thousands of Earth years, most of it in a darkness where noon is only a suggestion. These remote companions whisper that the solar system is not a tidy string of 8 or 9 jewels, but a broad and patient family, with cousins who rarely visit and yet belong. All of this scale was sketched when the sun was young and wore a disk of dust. Grains collided and clung, pebbles grew into mountains, mountains into worlds. Giants migrated, tugging smaller bodies, clearing some lanes and roughening others. Some stones stayed near, some were flung outward to sleep. The distances we measure today are fossils of that early choreography, written not in bone, but in orbits. Our eyes and tools keep improving, and with them, our patience. Telescopes read weather in alien skies, count whisper-thin rings, and map scars in rock like tree rings you can touch only with light. Computers let us rewind the dance and play it forward, testing how a nudge here might open a wide gap there, and still, the immensity keeps its power to quiet the mind. Knowing a number does not erase the hush that number implies. It only lets the hush be appreciated with more care. Scale shapes every journey we dream. The farther we hope to go, the more softly we must plan. Navigation becomes a listening, hearing the faint invitations of gravity. Timing burns to match the music. Distances turn bold intentions into rituals of patience. Calibrate and wait. Correct and wait. Aim and then wait again. This is not discouragement. It is the tempo of a place where even light takes its time. Through it all, one star keeps gentle time. The sun may be ordinary by galactic standards, yet it is indispensable here. It sets the seasons on a small blue world, braids, rings from dust at Saturn, wakes comets into brief flowering, and holds worlds in lanes so reliable that winter knows when to arrive. Across a domain so wide that hours are needed for light to cross it, one heart beats steadily, warm and exact, and we, small and fortunate, drowse under its glow, listening. Distances here are not only large, they breathe. Orbits are gentle ellipses, so closeness and remoteness ebb and flow with the seasons. Earth leans inward in early January perihelion at about 147 million kilometers from the Sun, then leans back in early July aphelion near 152 million kilometers. Every planet keeps a similar sway, each path its own oval thread, so the solar system is never frozen clockwork, but a living mobile, tilting and gliding in slow harmony. Size and distance make small miracles. From rooftops, the sun and moon appear the same size, because one is about 400 times wider and about 400 times farther away. That near match lets daylight briefly fold into twilight during a total eclipse, the corona lifting like a pale flame. At other times, a planet crosses the sun's face as a tiny bead, a transit proof that perspective can turn enormity into a speck and still carry meaning. Scale stretches through time as well as space. Worlds spin at different tempos. Jupiter whirls once in just under 10 Earth hours. Neptune takes more than 16. Orbits slow the music further, and the long, soft tug among planets writes changes that unfold over millions of years, nudges only patience can see, like dunes crossing a desert, one grain at a time. Small travelers reveal how energetic the quiet can be. Meteoroids and asteroids move at profound speeds, their paths long and their meetings rare, yet sometimes a small stone and a planet share a moment. In 2013, above Chelyabinsk, a fragment rushed into our air at about 19 kilometers per second and blossomed into sound and light damage on the ground, awe in the sky. A reminder that even pebbles in this realm carry the momentum of great distances. To travel between neighbors is to rethink far and soon. Fuel is cherished, burns timed to gravity's heartbeat, and waiting becomes part of the work. Engineers answer with ion drives that sip propellant, gravity assists that borrow speed, and trajectories woven like careful embroidery. What once felt abstract turns into a roadmap you can trace across star charts and screens. Holding this breadth in view makes Earth feel both modest and extraordinary. A small world, yet tuned for liquid water, weather, and breath. Sunlight arrives in a generous band, a large moon steadies our tilt, and oceans ferry heat like lullabies. Against harsh distances and radiation elsewhere, this blue room is a sanctuary that teaches gratitude alongside curiosity. Far beyond the planets, the solar system softens into almost memory, a distant reservoir of icy bodies, the Oort cloud that may reach tens of thousands of astronomical units in every direction. Orbits there take millions of years. Most of a comet's life is spent asleep until a whisper of gravity changes its course. At those margins, the sun's authority is suggestion more than command. Its reach real, yet almost invisible. Human messengers have tested these reaches. New horizons crossed the cold and, after roughly 9 years, met Pluto in 2015. In the dim lantern light of a far sun, it found mountains of water ice, plains of frozen nitrogen, and hazes stacked like veils in a thin atmosphere. Signals took hours. Instruments drank meager sunlight. The spacecraft kept its own counsel between commands. Every kilometer was a lesson in patience. Ideas about going farther carry practical weight. Outposts beyond Mars, beneath Europa's ice, in Titan's amber skies, would live at distances counted in millions and billions of kilometers, with journeys measured in years. Life support must become a garden that tends itself. Propulsion, steady and frugal. Crews settled into a rhythm where waiting is work and quiet a companion. Even the short step to our moon teaches the grammar of the long road. A path only about 400,000 kilometers demands precise timing, attention to tides of mass and motion, and an ear for resonance between world and vehicle. The same skills scale outward, to Mars with transfer windows, to the giants with gravity assists, to the outer dark with instruments that know how to sleep and wake. While spacecraft fly, telescopes and mathematics keep score. Radar ranges a planet with a measured echo. Parallax turns Earth's orbit into a baseline. Telemetry carries whispers of velocity and position through the void. Astronomical units and light minutes become friendly units, a shared language that turns a silence of billions of kilometers into a map we can fold and study. Perspective gathers in the quiet. A system this large invites humility. Even Jupiter is a bead against interplanetary emptiness, and our lives are brief compared with an orbit's slow thought. Yet humility here does not diminish us. It opens a door for wonder, for the old question of how life learns to travel and endure, for the hope that minds born on one world can understand many. What looks empty is busy at subtle scales. Between planets drift grains of dust and streams of charged particles. The solar wind flows outward. The sun's magnetic field spirals. Cosmic rays arrive from distant catastrophes to test every shield. Effects accumulate over distances so wide that only careful instruments and long attention can trace them, like hearing the sea by listening to a single shell. The smaller citizens dwarf planets, asteroids, comets, range from a handful of kilometers to more than 2,000 across, each holding to a path kept by gravity's patient bookkeeping. Together they gather into belts and clouds and rings, adding texture to a structure already immense, reminding us that grandeur is often the sum of many small motions kept over long time. Our maps have grown from chalk sketches to three-dimensional ephemerides that predict worlds billions of kilometers away. Early watchers used sight and courage. Now, spectrometers weigh air, cameras count boulders, and clocks keep time so exact that a tiny error could send a craft hundreds of kilometers off course. Knowledge stretches with the distances, a reaching that mirrors the orbits it seeks to understand. Behind these pictures is a gentle mathematics where mass, distance, and time speak. Equations turn vastness into order, show how a small deviation today becomes a great wandering after eons, and reveal that stability is not stillness, but balance, many pulls summed to a calm. In that balance the solar system feels both grand and intimate, a wide, breathing architecture we can measure, navigate, and slowly learn to travel with care. Starlight feels close to the skin, a shimmer above rooftops, yet the stars are far beyond any day's horizon. Even the nearest neighbor after our sun sits across a gulf that outgrows simple imagining. Alpha Centauri is about 4.37 light-years away. A single light-year, the distance light crosses in 1 year, runs to roughly 9 trillion kilometers. Light itself hurries at nearly 300,000 kilometers each second, and still, it needs more than 4 years to stitch that gap. What looks like a pinprick is a voyage measured in years, and the sky is stitched from such long threads. Numbers grow steadier when we hold them gently. Proxima Centauri, the small red companion in that system, is a touch nearer, at a little over 4.2 light-years. Voyager 1, our swiftest, long-lived messenger, sails around 17 kilometers each second at that valiant but human speed. A crossing to Proxima would take on the order of 70,000 years longer than cities have existed, longer than the ink of history. The span between stars is measured not only in distance, but in generations. Other neighbors keep their distance with calm certainty. Barnard's star lies roughly 6 light-years away. At current speeds, such a journey would outlast languages. Sirius, bright and insistent in winter, beams from more than 8 light-years. Epsilon Eridani, a youthful sun at about 10.5, joins the local chorus. Even so, our galaxy is vast beyond these introductions. The Milky Way is a whirl more than 100,000 light-years across, and between its stars lies a mostly silent medium-thin gas, magnetic fields, dust fine as smoke, so that traveling from one star to the next is less like walking city blocks and more like crossing an ocean that keeps inventing new horizons. Thinking about travel turns the mind to time. The moon sits a few 100,000 kilometers away, Mars tens of millions at its friendliest approach. Both are errands compared with the star-to-star gulf. Suppose a craft reached 1/10 the speed of light, unimaginably swift compared with today's engines. The run to Alpha Centauri still lasts over 40 years by the clocks on Earth, a whole working lifetime spent in the dark between suns. And that fantasy leaves out the difficult rhythm of speeding up without braking, of shielding living tissue from cosmic rays, of slowing down gently so that arrival is a greeting and not a flyby. Light carries the past into the present as a gentle courier. Photons arriving tonight from Proxima departed more than 4 years ago. Those reaching us from stars hundreds of light-years away began their trip before our grandparents were young. Some light in the sky left its home when empires were fables. Some when ice ruled valleys where towns now stand. Distance in the night is also time. The farther we look, the older the message. So each star is both a place and a long ago. Energy is the stern master of interstellar dreaming. Chemical rockets are faithful for planets, but they wither before the arithmetic of the stars. To cross such gulfs in decades rather than millennia would demand propulsion that sips little and gives much, nuclear pulses, or fusion winds, beamed light pushing a sail, perhaps even matter-antimatter engines from equations we have only skimmed. A craft would need a skin against radiation, a patient heart of power, and a way to turn speed into arrival without wasting the very energy that made the trip possible. The distances do not mock us. They tutor us in what we have yet to learn. Even when no one rides aboard, difficulty persists. The voyagers left the familiar wind of the sun and entered interstellar space, still speaking in whispers across more than 20 billion kilometers. At their pace, Alpha Centauri is not a destination but an idea. Against that measure, Apollo's 3-day sprint to the moon feels like a soft step across a room. Each extra zero added to distance multiplies the patience required, turning a simple arrow on a map into a choreography of decades. Distance also changes conversation. Signals are bound to the speed of light. A message sent to the nearest star would arrive years late to any waiting ear, and the reply would take years more. Guidance cannot be live. Governance cannot be immediate. Affection must learn to stretch and trust. Any village under another sun would keep its own calendar and customs because time itself would insist on local ways. The future out there is slow by design, and that slowness would shape every habit. Even so, we learn a great deal from here. Telescopes weigh stars and watch their small wobbles. Others catch delicate dimmings when a planet crosses a stellar face. Proxima hosts at least one rocky world in the temperate zone, where liquid water might be possible, a whisper of a shore we cannot yet visit. For now, we read its clues. A tug in the star's spectrum, a faint blink in brightness, a hint of weather inferred from light that has traveled trillions of kilometers to touch our mirrors. Close enough to study, too far to touch, yet the mind travels there easily and returns with patient questions. Holding the scale against our own yardsticks makes home clearer. The sun's protective bubble, the heliosphere, reaches outward for a span measured in light hours, not even a full light day, before yielding to the great sea between stars. Alpha Centauri waits thousands of times farther than that boundary. Farther still, the distant reservoir we call the Oort cloud may extend for a fraction of a light year or more, comets sleeping through ages until a nudge sends them inward to grow a veil and briefly burn like a thought. Between these shells, the interstellar medium flows like a very thin weather, shaping and being shaped by the sun's outbreath. Dreams of travel become designs, and designs become questions about living. A ship bound for another star might carry families who expect to grow old under artificial skies, or it might be no more than a thin sail racing ahead of a beam of light, all circuitry and no breath. Perhaps both will fly robot scouts first, then habitats that are gardens with engines. In such journeys, fuel is not merely mass, it is strategy, harvesting energy along the way, skimming fusion from thin gas, turning starlight or starlight's echo into motion. The road asks less for bravado than for craft and care. Neighbors beyond Proxima remind us that the night is populous. Sirius sends winter light that began its trip more than 8 years ago. Epsilon Eridani's glow left when our calendars still marked a different decade. Their brightness is not proximity's trick alone, but power spread thin over unimaginable roads. We receive what remains after space has taken its share, and even that remainder is enough to cast shadows, to set a course, to stir the oldest ache of curiosity. Physics sets boundaries with a calm hand. Nothing outruns light, and near that limit, time itself bends. For travelers, clocks aboard a near-light-speed craft would tick more slowly than clocks on Earth. To those on the ship, the years might feel shorter. To those at home, decades or centuries would pass. Distance and time entwine until near and far depend on who is counting and from where. The puzzle is technical, yes, propulsion, shielding, life support, but also human, braided from patience, meaning, and the willingness to let different clocks be right in different rooms of the same universe. Perhaps that is what the nearest stars most clearly offer, a scale against which to measure our resolve. They do not refuse us, they simply wait. Between their light and our eyes is a curriculum of patience, an invitation to invent kindly, to travel gently, and to remember that every photon that reaches us has crossed a darkness and still arrived shining. Star by star, the universe teaches its long lesson, and we listen quietly, together, breathing with the rhythm of a distance that is also a kind of time. Proxima b circles the dim red ember of Proxima Centauri, and the thought of a small rocky world in the soft band where liquid water might linger feels like a warm light left on in a distant house. Astronomers keep listening and watching, measuring the star's tiny wobbles, timing delicate dips in brightness, and taking spectra that turn starlight into weather and chemistry. Each new hint is a thread tugging gently at imagination, a reminder that even the closest suns keep their secrets in fine print. Yet the most hopeful plans admit a simple truth. To touch such a world would demand flight times measured in decades for probes and likely generations for anything that carries breath. The lesson here is not a scolding, it is a soft humility. Nearby suns show us the outline of our tools and ask us to stretch calmly, steadily, toward tomorrow. To dream of crossing the dark is to accept slowness, to welcome craft, and to make peace with long intervals where waiting is the work. Starlight itself keeps faith over years. We can learn from that example without losing the warmth of hope. So we practice on nearer paths. Robot craft become patient scouts, learning how to sleep and wake, how to sip power and speak across a gulf. Telescopes on mountaintops and in orbit walk for our eyes. With spectroscopy, astrometry, coronagraphs, and careful image processing, they pull faint planets out of glare, weigh their orbits, and sniff the thin air around them for water, methane, or the crisp signature of oxygen. Each measurement is a small bridge thrown across a broad silence. None of these techniques shortens the road by magic. Together, they make it legible, turning guesswork into maps. Some dreams sketch hardware in the margin of the night, beamed light sails as thin as thought, fusion engines like tame stars, nuclear pulses folded into a rhythm, magnetic scoops sipping fuel from the sparse interstellar medium. The ideas must solve for speed without breaking the travelers, for shielding without too much weight, and for arrival that is not only a blur. Even the fastest plausible probes would still take decades to reach Proxima. Messages would lag by years. Course corrections would be scripted long in advance and left to the craft to execute with quiet autonomy. Hope and prudence walk together. We keep refining the art of living far from home life support that behaves like a small forest, power systems that hum for years, navigation that listens for gravity's quiet cues. We rehearse with journeys to the outer planets, where sunlight is thin and delays are long, learning the calm that deep space demands. Each success is modest when told in minutes, enormous when told in miles, and quietly transformative when told in lessons learned. The stars do more than tempt, they educate. Counting in light years and decades reshapes our sense of time. A future settlement orbiting a nearby sun would be local in the truest way, governed by its own weather and clocks, because conversation with Earth would move at the speed of patience. 4 years there, 4 years back, every question a letter, every answer an act of trust. That delay changes how we design missions, how we imagine responsibility, how we picture community and consent across a distance that turns guidance into advice and advice into memory. From the ground, we continue to map and to wonder. Precision surveys watch nearby stars drift against the deeper tapestry, measuring motion subtle as a heartbeat. Direct images show small crescents beside blazing suns, the way a firefly can be seen at dusk if you shade your eyes. Some worlds are warm and stormy, some are dim and quiet. Some circle where water might last, others tilt and scorch and freeze. We still guess at their colors and winds, but the guesses grow better each season, and with them, our questions grow steadier and kinder. The nearby suns also put our own frontier into scale. The heliosphere, our star's protective outbreath, swells and contracts with the solar cycle, ending not at a wall but at a weather front, where the wind of other stars pushes back. Beyond, the interstellar medium carries thin dust and magnetic fields like threads of silk, and cosmic rays write a hard, bright script through everything that tries to cross. Any craft bound outward must learn these currents and seasons, as sailors once learned tides and trade winds, plotting not against water, but against invisible rivers of charged particles and the subtle tug of fields. None of this feels quick, and that is all right. The night sky has always been the slowest teacher, and its lessons stick. A child with a small telescope learns the names of a few bright stars. An engineer spends a decade building a sensor that can weigh the wobble of a sun, a whisper, more precisely than before. Added together, these fidelities become a long bridge. Step by step, we turn distance into something navigable, danger into something knowable, wonder into a discipline we can hand to the next pair of careful hands. The nearest stars are both lanterns and mirrors. In their light, we see where we might go. In their remoteness, we see what it will take from us: endurance, clarity, and kindness in planning. They are not goals for a season, but horizons for a civilization. If we ever leave the solar system in earnest, their neighborhoods will be the first we try to join. And the work we do now, patient, precise, tender with truth, will teach us how to arrive gently. Until then, we watch. We collect spectra like postcards. We refine our clocks. We practice steering by whispers and reading weather made of particles and light. And we keep a quiet promise with ourselves to let the scale of the universe make us thoughtful rather than small, to let its difficulty make us careful rather than hard, and to let each steady point of starlight remain what it has always been, a beacon for the mind and a lullaby for the heart that means to travel. Long before engines learned to breathe fire, people lay under velvet skies and traced routes no ship could sail. Stories carried them, chariots in the Milky Way, ladders of light, travelers stepping from star to star as easily as crossing a stream. Those tales were lanterns hung in the dark, not blueprints, yet they kept the question warm. What would it mean to reach a point of light and find it close enough to touch? Centuries turned, and the dream put on a coat of reason. The oldest myths softened into early science fiction, and imagination began courting mathematics. In the 19th century, writers like Jules Verne and H.G. Wells dared to sketch journeys that listened, at least a little, to physics. Verne pictured a daring launch to the moon, powered by a colossal cannon, impossible to our modern eye, yet remarkable for how it wrapped wonder around calculation. Wells swung the lens the other way, asking what it would feel like if visitors arrived from strange suns, turning distant stars into plausible addresses. Their pages did not lift rockets, but they trained the gaze outward and made distance feel discussable. Soon, a doorframe took shape. In a quiet room far from launch pads, Konstantin Tsiolkovsky wrote down an equation that turned fuel and mass into escape. His rocket formula read like a stern promise. More velocity demanded more propellant, and the curve of enough rose fast. He imagined metal ships and, beyond them, sails of light. He even pictured slow arcs where generations would grow beneath artificial dawns on the way to another sun. The arithmetic was strict but not unkind. It told us why leaving is hard and showed that hard is not the same as impossible. Other minds joined. Hermann Oberth gathered principles into a grammar of flight, pointing first to planets and, with a steady finger, past them. Nuclear energy took a seat at the table, not as menace but as concentrated push. In American fields and deserts, Robert Goddard coaxed liquid fuel to life, a thin flame lifting an idea while headlines mocked and neighbors wondered. Guidance, cooling, control. His careful answers were small, necessary miracles, the quiet craftsman's work beneath every headline that would follow. History sped the lesson. War taught engineers to shape engines that could climb out of air. Afterward, the same minds looked upward and saw steps where they had seen trajectories. The first rockets that kissed the black were not starships, but they proved the vocabulary, thrust sufficient to escape, guidance that could think while falling, structures that endured both fire and cold. With that path came bolder sketches. Mid-century studies proposed engines that pulsed to the beat of small suns, nuclear explosions tapping the stored heat of atoms to kick a craft again and again. Robert Bussard imagined a magnetic scoop wide enough to gather interstellar hydrogen and feed a fusion furnace, a way to carry almost no fuel and still cross between stars. Audacious, yes, but not whimsy. Chalk, dust, and calculus kept them honest, even as reality kept them waiting. Fiction walked beside these drafts, bright-eyed and attentive. Isaac Asimov built empires and riddles between suns. Arthur C. Clarke balanced wonder with engineering so gently that geostationary satellites lived first in an essay before becoming the nerves of our communication. Poul Anderson sent crews on voyages where time thinned and centuries folded, and readers learned the rhythm of relativistic clocks the way sailors once learned tides. Stories tried on futures like garments, testing seams for where life would chafe or flourish. The studies themselves grew more exact. Tables replaced bright guesses. Masses, cross-sections, and delta-V budgets took their seats at the desk. Project Orion set out the startling arithmetic of nuclear pulse propulsion. Plate, bomb, shock absorber. Repeat a drumline that might push a ship to a respectable slice of light speed if treaties and stomachs could bear it. Light sails moved from metaphor to calculation. Sheets of gossamer pushed by sunlight or by lasers bright as artificial noon. Antimatter peered from the edge of feasibility, its energy dazzling, its handling sternly impractical. Relativity stayed in the room as the quiet moderator, reminding us that no engine argues with light. As equations multiplied, a quieter accounting took shape. If a ship needed decades or centuries to cross, how would a culture breathe in a sealed habitat? Gardens would have to recycle every breath, water would always be yesterday's rain, and a school would teach history that no one aboard remembered because launch day belonged to the dead. Psychologists and ethicists stepped in. Consent, governance, and the art of staying kind in small rooms joined mass ratios and heat rejection on the whiteboard. The obstacle was not only thrust, it was trust. Some proofs of heart left the solar system anyway. In 1977, two small travelers, Voyager 1 and 2, threaded the gravity of the giants and kept going past the sun's weather into the wider wind of the galaxy. Behind them, rode a golden record, music and greetings tucked into the dark like a bottle set adrift. They will not reach another star in any useful span, but they taught patience, autonomy, and the craft of instruments that whisper for decades without complaint. Ideas kept gathering mass. Freeman Dyson sketched habitats big enough to feel like countries, sunlight captured and shared. Carl Sagan reminded anyone who would listen that we are star stuff grown capable of missing the stars. Solar sails flew in miniature. Laboratories teased more steadiness from lasers and dreamed of aiming them across the void. Fusion kept its promise at arm's length, yet its horizon inched forward. A more recent sketch has the delicacy of a firefly. Gram-scale probes with cameras and chips clipped to sails only atoms thick, pushed by ground-based lasers until they skim a fraction of light speed and coast toward Alpha Centauri. Breakthrough Starshot gave the idea a name, and a design brief fit a star probe into something like a postage stamp. Make the sails smart enough to steer a little. Make the beams steady enough to push without tearing the fabric. Arrival would be flyby rather than parking, snapshots rather than camping. Yet even a sliver of image from Proxima's neighborhood would be a postcard from a shore we've only drawn from hints. Through all of this, a pattern is easy to feel in the dark. Imagination moves first, science paces after, and engineering arrives with careful hands, deciding what can be gently made true. Myth yields to math, and math keeps wonder honest. The line from Verne's canon to Tsiolkovsky's equation to laser sails is not straight, but it is steady, like a path worn by night walkers between two trusted houses. What these generations reveal is less a countdown than a practice. Each cohort writes a little more of the dictionary needed to speak with the stars. Materials improve. Instruments learn to taste light for the flavor of water and oxygen in an exoplanet's air. Spacecraft become good at sleeping and waking, at steering themselves when conversation with home is too slow to help. The dream remains far, yet the reach grows articulate. None of this insists on hurry. The scale of the problem sets the tempo of the solution. We are learning to keep time with an orchestra that plays in decades, to accept that some answers will arrive in the voices of people not yet born. That acceptance is not surrender. It is a love for continuity, a willingness to be part of a story longer than a single life. So the idea of traveling to the stars becomes a quiet meditation as well as a plan. Picture a sail unfolding like a silver leaf in the black, a pulse drive thumping like a measured heartbeat, a garden ship where evening falls along a corridor of trees, and a child learns the names of constellations that will look different by the time that child is old. Picture a robotic mote coasting past Proxima b and turning its thin face to send home a sliver of spectrum, the first postcard from a shore we have only guessed. Between here and there is work materials, power, ethics, navigation, the tranquil art of design that forgives mistakes. There is also the necessity of tending Earth with more care, because every star plan begins at this table, in this kitchen of air and water and soil. To be serious about leaving is to be tender about staying. And the two vows strengthen each other. When the night is quiet enough, the story resolves into something simple. People have always reached beyond what their hands could touch, then taught their hands to follow. The stars do not bend closer for our sake, yet they continue to shine with a steadiness that encourages. Between fairy tale and flight plan lies a long, breathing corridor of thought, and we are already walking in it, soft-footed, unhurried, carrying both instruments and lullabies. Across centuries, the daydream of reaching the stars has been a quiet thread through human nights, changing its fabric as our tools and knowledge changed. Myths gave way to fiction. Fiction learned to speak with equations, and equations invited metal, fuel, and flame. What began as a candle-lit story now lives where physics, engineering, and creativity overlap, still tender, still distant, but no longer shapeless. Each generation takes the long breath of the one before and carries it a little farther, and the stars keep their patient place, like calm listeners at the far end of a long conversation. The heart of the dream remains simple, a small ship leaving a warm home and gliding into the dark. Yet the dark is large, and the ships we have were built for a neighborhood, not the ocean. Chemical rockets, magnificent for climbing out of gravity's cradle, were tuned for orbits, moons, and planets. They trade fuel for speed, with a grace that ends quickly. The more propellant we carry, the more mass we must push, and the curve turns steep like a mountain path in thin air. Specific impulse, the measure of how efficiently a rocket turns propellant into thrust, sets a limit that no optimism can charm away. To reach even a modest slice of light speed with chemistry alone would take fuel on fuel until the ship became mostly tank and almost no journey. Even our swiftest emissaries confess the scale. A probe that skims the sun at hundreds of thousands of miles per hour is a marvel of heat shield and grit, yet that furious pace is only a tiny fraction of light's speed. At such a clip, the nearest star remains many long human eras away. These numbers are not meant to discourage. They are the quiet arithmetic of a very large room. So minds turn toward other fires. Nuclear thermal designs promise hotter exhaust and better economy, heating lightweight propellant in a compact reactor and pouring it starward as a faster plume. Nuclear pulse concepts imagine a drumbeat of small, controlled blasts cushioned by clever shock absorbers, startling, potent, and heavy, with ethical and political knots to untie. Ion engines already hum in space, trading feather-light thrust for exquisite stamina, sipping propellant and rewriting orbits with patience measured in months and years. They are perfect tutors for deep space etiquette, but at their current strengths, they are flutes, not trumpets. For the interstellar symphony, we still need more instruments. Energy is the other stern teacher. To push a meaningful craft to a tenth of light speed would demand stores of power that rival civilization's decades of work. Storing that energy safely, delivering it smoothly, and shedding the waste heat without cooking, the ship turn a simple arrow on a drawing into a cathedral of engineering. And the medium between stars is not empty. Grains of dust and stray atoms hit like tiny meteors at high fractions of light speed, while cosmic rays and magnetic fields write hard, bright lines through any unguarded hull. Protection that is strong enough to help is heavy enough to hurt. And so design becomes a balancing act with very fine fingers. The boldest ideas sit at the edge of what we can touch. Antimatter gleams with the clean promise of E equals mc squared turned almost fully into motion, yet we can make only whispers of it, keep it only in traps, and must never let it kiss the wall. Fusion offers the slow thunder of stars in a bottle, if only the bottle would hold. Great laboratories learn a little more of that spell each year. Beamed light sails change the question entirely. Let the ship be as light as a leaf, and let distant power do the pushing. A sail of gossamer, a laser-like artificial noon, a flight measured in decades rather than millennia. Suddenly, the word within enters the sentence about a human lifetime. Steering, aiming, and slowing at the far end, remain formidable, but the door feels less imaginary. Even if propulsion bowed to our wishes tomorrow, the rest of the journey still asks for wisdom. A crude craft is a garden wrapped in engineering air that must be endlessly tidied, water that must turn in circles, food that must be grown with the patience of farmers who will harvest what their grandparents planted. Shielding imposes mass. Mass demands more push. More push demands more power. The spiral returns to the first page. Robots will likely go first, and often precisely because they are frugal with life's fragile needs. They can sleep deeply, wake on schedule, repair themselves with spares and software, and keep flying long after an anthem would fade. The laws that frame these problems are not enemies. They are the rails on which honest progress moves. Light speed remains the limit. Near that threshold, time itself loosens and stretches. Clocks on a very fast craft would run slower than clocks at home, so the decades felt aboard could be longer on Earth. Conversations would move at the pace of patience, years out, years back. Guidance would be a letter, not a conversation. Leadership would be local by necessity. A village under another sun would carry our language and stories and care, yet it would learn to stand on its own in the deep quiet. Between the hard edges of physics, softer arts continue their steady work. We practice living far from home with missions in the deep cold where sunlight is scant and signals lag. We perfect closed-loop life support and gentle, durable power. We refine how to sleep a spacecraft for years and wake it without panic. We teach instruments to sip energy and speak clearly after long silences. We learn to listen to gravity the way a sailor listens to the wind, stealing speed in careful flybys and returning it when we must slow. Telescopes, meanwhile, read starlight like a library. Spectra reveal the fingerprints of water, methane, and oxygen. Timing tracks the tiny stagger of a star tugged by planets we cannot see. Coronagraphs and starshades peel glare away to reveal faint crescents of distant worlds. These are not shortcuts, they are orientation. Knowing which stars hold rocky planets in temperate light, which atmospheres breathe gently, which systems are calm or stormy. This is the map-making that precedes any long walk. None of this requires drama. The universe, generous and stern, rewards steadiness. Fiction continues to try on possibilities, giving us rehearsal space for ethics and culture aboard generational ships, for agreements that will have to last longer than memories. Workshops and journals pick up where stories leave off, turning bright maybes into constraints and then into designs. Along the way, humility remains a companion rather than a scold. We are small, that is true. Our questions are large, that too is true. Between the two lies craft. Perhaps the gentlest truth is that tending Earth and dreaming of departure are not opposites. The better we become at keeping air sweet, water clean, soil alive, and systems resilient, the more credible any long voyage becomes. A ship that can cross to another sun is, in spirit, a very careful city. A civilization that can build one will have learned kindness toward closed worlds, especially the blue one that taught us how to live. So the thought of interstellar travel settles into the slow rhythm of breath. We test engines that trade flame for patience. We unfold sails that feel pressure from light. We model fusion that might one day purr rather than roar. We sketch laser arrays on mountaintops and in orbits, and we ask our mathematics to keep us honest about heat, momentum, and risk. We accept that some work belongs to those not yet born, and we try to leave them tools rather than troubles. The stars remain as they have always been, near enough to name, far enough to humble. They are not promises of quick victory, but steady beacons for careful minds. If we ever slip beyond the sun's last weather and aim for another dawn, it will be because patience grew into skill, and skill grew into trust, and trust grew into a ship that carries both instruments and lullabies. Until then, we practice, measuring, listening, refining, letting the vastness make us precise, letting the difficulty make us kind, letting the dream stay bright and warm as we drift towards sleep. The way a sail leans into a light wind and moves, almost invisibly, across a dark and welcoming sea. Atomic fire entered our imagination like a second sunrise. When we learned to split the nucleus and sit with the hush after the flash, a quiet thought arrived. Could that deep, steady energy carry a ship across the long dark? Chemical rockets are bright and brave, but they gulp fuel and fade. Nuclear power feels like a calmer flame, less propellant for more reach, letting distance unspool the way a night road opens beneath soft headlights. One of the earliest, boldest sketches wore a simple name: Orion. Imagine a broad metal plate at a ship's stern, resting on shock absorbers like quiet knees. Behind it, small nuclear charges pop in a metronome of light: flash, push, settle, flash, push, settle. Each blossom slaps the plate, and the craft rides the pulses the way a skiff rides a gentle, insistent tide. Because nuclear energy is millions of times denser than chemical fuel, payloads could be generous and trips shorter. In old drawings, Orion looks like a slow, sturdy city setting out. Awe came with a shadow. Detonating nuclear devices in space invited hard questions about fallout, law, and responsibility. After the world learned to stop open testing, it would not make an exception just because the target was distance. Even without treaties, engineering would have spoken sternly: a pusher plate that never fails, shock absorbers that turn violence into glide, materials that keep their strength after thousands of slaps. Orion was not fantasy. It was a teacher, showing the line between hard and not yet. Another path kept the flame but skipped the blasts. Nuclear thermal rockets place a compact reactor at the heart of a familiar engine. Light propellant, often hydrogen, is heated to extreme temperatures and roars through a nozzle, faster than any chemical exhaust. Mid-century tests proved the principle: steady thrust, far better efficiency, no bombs in the wake. These engines point first to Mars and the outer planets, shaving weeks or months from dangerous transits and training crews in the unhurried rhythms of deep space. Quieter still are nuclear electric systems. Fission heat becomes electricity, and electricity feeds ion or Hall thrusters that fling charged particles away at extraordinary speed. The push is gentle, more a long hand on the shoulder than a shove, but it almost never stops. Day after day, a craft gathers speed the way a river gathers width. With enough time, these engines carve paths no chemical rocket can sustain. They suit robotic scouts, first patient travelers that can sleep and wake, sip power, and whisper home from far away. As confidence grows, imagination reaches for brighter matches. Antimatter sparks to light fusion fuel, micro-explosions tamed to a steady drumbeat, magnetic bottles to hold star heat long enough to turn it into motion. On paper, such engines promise fractions of light speed that draw nearby suns out of millennia and into the realm of decades. In the workshop, they remain seedlings, real physics wrapped in materials and control problems that ask for breakthroughs rather than small steps. Hope stays, but it learns patience. Nuclear dreams carry cultural weight. A ship riding atomic pulses is both lullaby and thunder in a single image. The same fire that can warm a voyage can also harm the world that launches it. That doubleness braided the history. Cold War fear and accelerating skill, treaties that drew lines in the sky, public moods that shifted like weather. Engineers learned to carry ethics like another tool in the belt, answering not only can we and how, but also should we and under which rules. Even with knots to untie, the thread never snapped. Lessons from Orion and from reactor tests seep into today's proposals. Materials behave better under heat. Reactors can be designed small, steady, and safe enough to power craft or outposts with a gardener's reliability. Electric propulsion has moved from paper to practice. The vocabulary grew richer. Specific impulse for efficiency, power to mass for what truly matters, delta V budgets like shopping lists for journeys. None of these pieces is a ticket to the stars alone, but together they sketch a sturdier bridge. Practical hurdles remain patient and plain. A deep space nuclear ship must carry its own weather, heat routed outward through radiators that glow like dusk, radiation tucked behind water, fuel, or specialized shielding. Neutrons and gammas accounted for, so that instruments and bones stay calm. Waste heat is not a note you can ignore. It sings a craft apart unless given elegant exits. Mass resists every flourish. Each extra kilogram of shield or structure must be pushed forever, so every kilogram must earn its passage. The medium between stars adds its own terms. Dust and thin gas drift in magnetic fields that curl like slow smoke. At high speeds, a grain of sand hits with the temper of a bullet. Nuclear or not, any starbound design must make peace with that rain by shielding, by clever angles, by choosing velocities ambition can sustain. Long quiet erodes as well. Cosmic rays nibble electronics. Lubricants forget their youth. Tiny flaws remember their birth and choose another day to fail. Reliability becomes an art of modesty and margin. Because the problem is wide, the approach stays layered. Robots first nuclear electric tugs moving cargo to Mars or the outer planets, teaching us how radiators age and how reactors hum in vacuum. Then perhaps crude stages using nuclear thermal propulsion to cut travel time and risk. Later, if patience holds and materials oblige, pulse systems or fusion lean engines that begin to bend interstellar flight from impossible to pending. At each step, we keep the habit of sleep and wake, designing for years without drama. Stories walk beside spreadsheets. Writers' people imagine corridors with gardeners and mechanics. Ethicists ask what consent looks like on a multi-generational craft. Mission planners fold rest into duty so the long days do not turn heavy. Culture rehearses what hardware cannot yet stage. In rehearsal, fear softens into caution, and ambition settles into stewardship. What nuclear propulsion finally offers is a change in tempo. Chemical rockets sprint, electric thrusters stroll. Nuclear systems promise a steady jog that goes on and on, a pace that matches the size of the map. They do not pull the stars close. They make the road less cruel. They teach that power, to be useful, far from home, must be patient, and that patience, to be useful, far from home, must be powered. Picture a ship in the outer dark, radiators spread like wings, dimly red against black, a compact heart of fission murmuring at the center, ions whispering into a pale ribbon. a crew checking slow instruments, then dimming the lights. Or, years before any crew, a robotic craft with the same red wings, steady and undecorated, sailing past Neptune with a gardener's faith in schedule. Each is a line drawn gently toward a brighter point, proof that with care and time, stubborn distances can be taught to yield. Nuclear dreams are not shortcuts. They are tools for keeping the promise between our curiosity and the true size of the night. They ask for courage without hurry, exactness without coldness, ambition that remembers the home that fuels it. If ships ever carry human breath into the spaces between stars, they may hold a small piece of sun at their center, a disciplined warmth, a heart that does not race, beating years into a careful rhythm. Until then, we keep learning the quiet crafts that such a heart would need, moving heat like water, folding danger into design, letting power be generous and exact, while we rest under starlight that has traveled so far to reach us, and drift a little closer in our thoughts to where it came from. Across decades, the story of nuclear propulsion reads like a lantern being turned up, notch by careful notch. In the 1,950 seconds, materials strained, electronics were young, and reactors felt more like laboratory vows than traveling hearts. Bold sketches such as pulse-driven ships pressed against the edge of what could be drawn, often farther than could be built. Today, modeling whispers answers. Before metal is cut, alloys keep their strength where heat lingers, and guidance systems trim courses with the steadiness of a surgeon's hand. Ideas once filed under fantasy step into the light as cautious candidates, still shadowed by safety, cost, and the care we owe the places we pass through. A quiet abundance of designs shows how many ways a nucleus might be asked to become motion. Pulse concepts promised quick, insistent steps. Nuclear thermal engines offered steady thrust from a hotter breath. Nuclear electric systems traded force for endurance, building speed the way a river gathers depth. Each approach balances a different triad: speed, efficiency, and risk, with payload mass as the fourth companion in every conversation. None is a silver key, and yet together they map a corridor through which deep space ambition can walk without hurrying, learning as it goes. Even as commerce opens new lanes to orbit and beyond, the old lessons speak softly but clearly. Distances remain stern, energy remains dear. If anything is to cross to the colder margins quickly, it will likely carry a compact star at its center, fission humming to electricity, or thermal glow turned into a higher, cleaner exhaust. Looking back at successes, missteps, and unfinished studies clarifies the boundary between what a patient century can do and what must wait for a brighter tool. The point has never been speed alone. It is the chance to enlarge the circle of the human room without tearing the fabric that makes the room livable. Practical benefits gather close to home first. A nuclear thermal stage can shorten a crew's exposure between Earth and Mars, trading months of drift for weeks saved, lowering the toll of radiation and the weight of supplies. Nuclear electric tugboats can shepherd heavy probes and cargo toward the outer worlds, where sunlight is thin and patience is the main propellant. With each mission, confidence accrues like interest. Radiators practice shedding heat. Shielding learns to be strong without being heavy. Long-lived power plants hum in the vacuum and keep their promises through winter dark distances. These engines do another kind of work. They stretch imagination without snapping it. Stories once painted, skies filled with atomic quiet flotillas, gardens and libraries moving between suns. Those tales were rehearsal rooms where ethics, culture and endurance could be tried on for fit. Engineers and physicists read them not as manuals, but as invitations to ask kinder, deeper questions. What does consent look like on a voyage longer than memory? How do you plant a flourishing culture in a sealed habitat? What kinds of failure are survivable when rescue is light years away? Step by step, advances in physics and materials turn those questions from theater to workshop. Reactors grow smaller and safer. High-temperature ceramics and carbon composites refuse to soften where old metals would sigh. Control electronics keep rhythm under hidden rainstorms of radiation. Simulations catch flaws on the page before they become cracks in space. The bridge from fiction to feasibility does not arrive all at once. It appears board by board, with each board tested, labeled, and placed by careful hands. Every time we speak about this power, the other half of the sentence deserves equal breath. To ride atomic energy into the dark is to accept its weight on conscience. How to keep space free of debris and fallout. How to protect instruments and future habitats. How to separate the engine of exploration from the machinery of harm. Treaties, norms, and public trust are not decorations. They are part of the vessel, like the radiators and the guidance computer. The craft must be engineered, not only for thrust and heat, but for grace, legal, ethical, environmental, so that the path behind it remains as clean as the promise ahead. The slow maturity of nuclear ideas changes more than itineraries. It reshapes how we think about home. A ship that thrives for years with closed-loop air and water, with gardens that recycle every breath, is a lesson in tenderness returned to Earth. To ready ourselves for long nights between stars, we learn to care for small worlds, and our first small world is blue, fragile, and near. Stewardship and exploration stop being opposites and become two halves of the same steady practice. What endures through all the versions, pulse plates, thermal cores, electric thrusters, is a recognition that the universe accepts only honest math and patient craft. Power densities that looked like spells become numbers we can manage. Risks that looked like walls become problems with handles. We still cannot promise swift human crossings to the nearest sun, yet robotic emissaries can go farther, faster, and wiser, and crewed journeys can become safer, kinder to the bodies and minds that undertake them. The stars do not come closer, we become more worthy of approaching them. Picture a near future that breathes rather than shouts. A Mars transfer burns a little hotter and arrives sooner, the crew stepping out less weary. A flotilla of nuclear electric explorers unspools toward the Kuiper Belt and beyond, their radiators glimmering like low embers, while instruments drink the dark. Data returns in a slow rain, rings mapped, atmospheres weighed, faint moons discovered at the edge of sunlight. Each result is gentle, precise, and utterly practical, and yet all of them together move the dream one quiet step toward the interstellar. Farther down the path, speculative engines keep their watch. Fusion waits for better bottles. Antimatter remains a beautiful arithmetic with no warehouse. Beamed sails lean on lasers that must be both strong and civilized. None of these asks for faith. They ask for patience, because new physics is rare and good engineering is time made visible. Meanwhile, nuclear systems we can touch continue to do their work, cutting months to weeks, turning impossibles into merely difficults, turning difficults into checklists. The appeal of these ships is not only scale city-sized arcs in old paintings, radiators like wings, crews numbering in hundreds, but also the way they illuminate who we are when we plan for distances our eyes cannot hold. We become methodical without losing wonder, brave without losing caution, ambitious without losing kindness. The atom gives us the means. The manner remains ours to choose. Starlight has always felt like a soft promise, near enough to find with a finger, far enough to elude the hand. For centuries we've whispered toward those distant embers, wondering what kind of engine could turn longing into motion. The answer that keeps returning, like a tide of bright mathematics, is fusion, the quiet thunder that powers the sun itself, tamed and shaped to push a ship through the dark. Fusion is a joining. Light nuclei, forms of hydrogen, meet under great heat and pressure, and in their embrace they release a river of energy. Our star does this with endless patience. On Earth we chase the same fire in pulses and rings, pellets crushed by light, plasmas sealed in magnetic loops, moments of star weather made in chambers rimmed with sensors, ignition for the instant, when a fusion burn gives back more than we pour in, has flickered on the edge of our reach. The work is delicate and demanding, yet the prize is generous. A fuel that is common, a reaction that can be clean, and an energy density that turns vast distance into something time can hold. When people first dared to sketch a fusion ship, the drawings looked like myths with equations in the margins. In the 1,970 seconds, engineers with the British Interplanetary Society drafted Project Daedalus, an unmanned craft almost 200 meters long, fed by pellets of deuterium and helium-3, ignited in rapid sequence to create a controlled hailstorm of microfusion. The plan was bold: reach Barnard's star in roughly 50 years by cruising near 12% of light speed. The numbers were honest, the materials ambitious, the spirit steady. For the first time, interstellar travel stepped out of poetry and stood, a little breathless, on the technical page. Other designs followed in that same hush of seriousness. A small American study, later called Project Longshot, imagined a probe to Alpha Centauri with deuterium helium-3 at its core and a compact fission reactor for housekeeping power. Inertial fusion rockets replaced a single furnace with many small candles pellets, lit by lasers or particle beams, thousands per second. Each burst a heartbeat toward the next star. The vocabulary grew. Magnetic nozzles to shepherd charged fusion products into a clean exhaust, shadowed bays to tame radiation, tanks and coils arranged like careful furniture so that heat would have a path to leave. The obstacles never hid. Fusion is a demanding guest. It requires temperatures where matter forgets old habits, pressures that ache for expansion, and cages of magnetism strong enough to hold a starlet still. In space, those demands multiply. Heat must be carried away through radiators that glow like low embers. Neutrons and stray particles must be caught by shielding that is stout but not heavy. The reactor's heartbeat must stay steady through decades when help is a light year late, and a ship is not only engine, it is guidance and food, antenna and memory, a home for instruments or for people who must weather the slow weather between suns. Yet the advantages remain luminous. Chemical rockets spend their story in a chapter. Fusion promises a whole book. With deuterium and helium-3, the reaction can favor charged particles over neutrons, letting magnetic fields turn raw energy into directed thrust with elegance. A fusion craft could accelerate gently for years, coast with dignity, then turn and break into a new sky. No single violent sprint, just a patient walk that becomes very fast because it does not stop. Nearby stars shift from millennia to decades. A message sent at launch might still reach its ship before arrival. Helium-3 itself has a quiet subplot. On Earth it's scarce. In lunar dust it may be more common. In the high airs of the giant planets, richer still. Mining it becomes a prelude to voyaging. Robots sifting gray soil by a slow horizon. Aerostats tasting the upper winds of Saturn or Uranus. Tankers refilling depots in cold, steady orbits. The fuel chain becomes a sketch of civilization growing outward, not a rush, but a rhythm. Even without helium-3, fusion's library is large. Deuterium-tritium burns hot and readily, though with a fiercer shower of neutrons to manage. Advanced PB, to the power of 11 reactions, whisper of almost neutron-free exhaust in exchange for even crueler temperatures and precision, a promise for later chapters. Magnetic mirrors, tokamaks, stellarators, Z-pinches, each confinement scheme is a different cup for the same fire, and each teaches us something we will need when the cup must travel. Earthside laboratories keep turning the dimmer up. Giant rings learn to cradle plasmas more gently. Superconducting magnets hold their strength like quiet giants. Lasers arrive in cleaner pulses. Diagnostics read the dance in real time. Places with patient names ITER in France, the National Ignition Facility in the United States, push the physics toward reliability. They aim at power plants, not starships, but the heartbeat is the same. A controlled, repeatable burn is the first true rung of any ladder that reaches away from the Sunday. The hazards between stars ask for care as well as speed. At a tenth of light speed, a grain of dust hits like a bullet. Cosmic rays write hard lines through circuits and cells. A fusion ship must carry clever armor, Whipple layers that turn pebbles into powder, fields that bend charged particles aside, perhaps a sacrificial fog of gas pushed ahead like a soft protective bow wave. Navigation becomes a quietly heroic art, choosing a path through an interstellar medium that looks empty and yet is textured like faint wind. If people are aboard, the ship turns into a garden with engines. Air and water circle back through leaves and filters. Heat finds radiators as surely as rain finds rivers. Days are made with gentle light and long hallways where footsteps are the clock. Artificial gravity is spun or tolerated. Sleep is honored the way power is conserved. The reactor's surplus warms greenhouses, hums through kitchens, runs the steady hum of health and repair. For decades, a small world must succeed at being a world. Fusion's influence would not stop at the airlock. A civilization that can bottle starfire for a ship can reshape its energy at home. Clean power that turns cities quiet and skies clearer. Factories that sip rather than gulp. Desalinators and district heaters and batteries that treat winter kindly. The technologies braid together. Better magnets for both reactors and spacecraft. New materials that shrug at heat. Robotics and autonomy that keep a watch without tiring. Even if nobody boards a starship for a long time, the path toward one brightens the floor under our feet. The numbers keep us honest. Proxima Centauri is roughly 4.2 light-years away. At 20% of light speed, the trip is a little over 20 years in transit and a handful more for speeding up and slowing down. Acceleration becomes a gentle constant, a millimeter per second each second, held for months until velocity gathers like snow. Deceleration mirrors it. Nose tipped toward a new sun whose light was ancient when the ship departed. The mission clocks are slow and deliberate. The purpose is larger than a single career and yet small enough for a single life to hold. Other technologies can braid with fusion to ease the edges. A magnetic sail could spread like a ghostly umbrella to break against a star's wind, saving propellant for science and return. Thin films deployed ahead could ionize dust to make it easier to steer aside. Artificial intelligence, built for patience rather than novelty, would tend the reactor, trim the nozzle, catalog the sky, and wake the crew, human or robotic, with only what matters. Autonomy becomes a kind of kindness, sparing minds the grind of routine while keeping hands on the essentials. Concept studies remain gentle beacons. Daedalus, Longshot, and their descendants show that physics does not forbid the trip. The barriers are practical: contain the fire cleanly, move heat politely, gather or carry fuel without turning the ship into a tank, make guidance unflappable, and repairs likely. Each decade adds one more how that used to be a whether. We do not lunge, we accrete. The meaning reaches past machinery. A fusion starship is a vow to do difficult things carefully, to move through the dark without scarring it, to become, slowly, a species at home in more than one light. It is not conquest, it's continuity, the same human habit of crossing valleys and seas, practiced on a stage where the curtains are time and distance. The stars do not need us. That is part of their grace. We go because we are curious, and because curiosity, when it grows up, becomes care. Picture the moment a first fusion messenger passes the sun's last weather and feels the galaxy's wind. Radiators glow faintly red, a low ember against cold. The exhaust draws a pale needle across nothing. Instruments sip power and look ahead with calm, unhurried eyes. Somewhere, years later, a tiny change in starlight confirms a planet's presence, or a spectrum carries the rumor of water. The images arrive thin and precious, like pressed flowers from a far summer. The room where people watch is quiet. The map on the wall grows an honest new line. If we step aboard ourselves someday, it will be because patience learned to partner with power. A ship will leave slowly, crewed by gardeners and technicians and a few poets, and in their long arc across a near-empty sea, they will think often of home, rivers and porches, clouds snagging on hills, the taste of rain. They will speak softly to machines that never sleep, and the machines will answer with numbers that sound like breathing. Decades later, another dawn will climb a different sky, and in that light, an old dream will feel simple. Fusion does not guarantee that day. It supplies a path that matches the size of the map, not a sprint, not a myth, but a long, disciplined walk under patient stars. Between here and there are pellets and coils, mirrors and magnets, treaties and trust, the slow craft of turning heat into kindness. Each year we learn a little more of that craft. Each year the dream loses a little fog and gains a little weight. Starlight invites the mind to wander, and sometimes it wanders to the boldest engine of all, a ship driven not by flame or by fusion, but by the meeting of matter and its mirror. Antimatter is the universe's perfect opposite. Every particle paired with a twin of equal mass and opposite charge. When the partners meet, they vanish into light and other swift children of energy. The arithmetic is elegant and unsettling. Mass becomes energy almost completely, just as Einstein promised. Even a pinch would release a storm of power far beyond any chemical fire, a brightness that feels more like starlight than flame. This near-perfect conversion is why antimatter feels like a star's secret handed to a traveler. Chemical propellants squander most of their mass in warm exhaust. Even fission and fusion convert only a modest fraction of what's possible. Antimatter, in theory, spends almost nothing and yields almost everything. Speeds that once sounded like myth, 10, 20, perhaps even 50% of light, slip into sentences that feel almost reasonable. Journeys to nearby suns turn from millennia into decades, from a story told to grandchildren into a voyage a single lifetime might greet at both ends. But the dream meets a careful dawn. We can make antimatter today, in bright rings, where particles are whipped close to light speed and coaxed to collide. What arrives is delicate and rare, mere nanograms in a year, at costs that make accountants blink. A starship would need grams or more, not whispers. Between nanogram and voyage stretches a canyon of engineering and energy generation, a new industry devoted to catching lightning in a bottle again and again, without dropping even a spark. Bottling is its own nocturne. Antimatter hates containers. Touch ordinary matter, and it shines itself into disappearance. So we cradle single ions and small clouds in magnetic and electric fields, penning traps, magnetic bottles, vacuums scrubbed clean, keeping the walls forever an arm's length away. For minutes and sometimes hours, this works beautifully. Scale it to kilograms, and the serenity breaks. The smallest contaminant, a jitter in a coil, a dust mote with bad timing, could bloom into a burst nobody wants to face. Precision becomes a way of life. Fields that never flicker, temperatures that never wander, diagnostics that watch without blinking. Even with storage solved, the energy arrives in fierce forms. Antiprotons and positrons do not merely warm a chamber. They produce sharp gamma rays and high-speed fragments that do not care about our plans. Turning that storm into push is the heart of propulsion. One family of ideas lets annihilation heat a working fluid hydrogen, most likely until it becomes a bright plasma, then throws that plasma through a nozzle that can survive its own brilliance. Another family reaches for more control, guide the charged products of annihilation with magnetic fields, gathering them into a directed exhaust, like a river braided into a single stream. Both ask for materials that keep their strength near the edge of fire, and for nozzles that remember their purpose under a glare that would humble metal. Speed, while merciful to calendars, is unkind to hulls. At a tenth of light speed, dust grains strike like bullets. Near a fifth, pebbles become artillery. A fast ship needs a patient shield, layered foils to turn stones into mist, a sacrificial cloud of gas pushed ahead like a soft bow wave, perhaps electric or magnetic fields to nudge charged specks aside. Radiation rides with speed as well. Cosmic rays, gamma flashes from the engine, secondary showers in the armor. The crew, if there is one, becomes a precious cargo of water and leaf and careful walls. Everything unnecessary is left behind. Everything necessary is doubled. Relativity arrives as a quiet companion. Clocks aboard run a little slow compared with clocks at home. To the travelers, decades might feel fewer. To those waiting, more. Signals lag by years. Guidance must be local and wise. The ship learns patience the way a monastery learns silence, making decisions without constant permission, preserving a culture of small repairs and steady checks that add up to safety. Then the ledger, the oldest ledger, opens. Making antimatter at scale would ask for power plants on a planetary budget and accelerators larger and thriftier than any we have built. Each gram would be the end of many careful steps: creation, cooling, separation, trapping, transport, and final storage, with failure never allowed. The costs do not merely add, they multiply. International compacts would be as necessary as cryostats. The word program starts to mean century, and calendars learn to breathe slowly. Yet curiosity keeps its candle lit because the prize reframes what is possible. A high specific energy fuel lets payloads grow and propellant shrink. A ship could devote more mass to shield and habitat, to instruments and landers, to the gentle extravagances that make long travel humane. We picture not only probes that glance and go, but expeditions that arrive with enough capacity to look closely, to linger, to learn. Meanwhile, antimatter research stays useful close to home. Positrons already help medicine find what's hiding. Antiprotons teach physics how matter is stitched together at its smallest scales. Better traps, cleaner vacuums, smarter magnets. These are not space baubles. They are tools for laboratories and industries that may never see a launch pad. The road to a star has branches that feed the village. Designers sketch many engines and accept trade-offs like weather. Antiproton catalyzed fusion uses a pinch of antimatter as a match, lighting conventional fuel to buy control and safety at the cost of complexity. Positron-heated concepts are gentler to store but harder to collimate. Gamma rays are stubbornly democratic about direction. Hybrid systems stack virtues and vices like stones. Fission for housekeeping power, fusion for the main push. Antimatter only for crisp, brief nudges when precision matters most. Every scheme balances energy density, controllability, waste heat, shielding, and the soft tyranny of mass. Safety is the chord that must never go silent. A microgram mistake is a weapon. A milligram is a catastrophe. Containment cannot be singular. It must be a chorus. Active fields, passive traps, sensors that never sleep, and fail-safes that fail softly. Autonomous guardians would watch faster than any hand could move. Legal frameworks would travel with the hardware, where fuel may be made, how it is moved, who inspects, who is trusted. The power to cross quickly is also the power to harm quickly, so responsibility becomes part of the machinery. Suppose, one evening far ahead, that production and storage have learned their manners. What then? A launch would still be quiet with concentration. Tanks would hum rather than slosh. Radiators would unfold like dusk-red wings. The engine would begin not with a roar, but with a rising note, as field lines settle and a working fluid brightens. The ship would not sprint from Earth like a thrown spear. It would climb into speed the way a river finds its valley steady, self-similar, and sure. The interstellar medium would speak in taps and whispers. Instruments pointed ahead would count rare atoms, taste magnetic filaments, and map the thin weather between suns. The bow shield would glow faintly from work well done. Inside, if there are people, life would slip into rituals that tame immensity. Meals on a clock, kinder than mission time. Gardens that sway in the ship's spin. Stories told so children can inherit a voyage that began before they were born and arrive before their hair is gray. Artificial minds, tuned for patience rather than novelty, would tend the engine, stitch small repairs, and wake the crew only when waking matters. All this lives in the conditional tense because matter and antimatter are still pen pals, not partners. Production remains a trickle, storage remains a violin balanced on a pin. Conversion to thrust is a classroom more than a hangar. The price is vast, the politics complicated, the ethics non-negotiable. Still, it's not wrong to let the mind drift along that corridor, feeling the shape of a technology that, if tamed, would redraw what far means. Antimatter also changes the questions we ask about exploration. If quick crossings become possible, do we visit more worlds briefly or a few worlds deeply? Do we send crews at all, or an armada of thoughtful instruments that can build laboratories when they arrive? How do we keep the sky safe for those who will follow, ensuring that fuel depots and busy lanes do not turn discovery into clutter? Answers will not be technical alone. They will belong to law, culture, and the quiet art of restraint. For now, the work looks like patience made visible, better sources for positrons and antiprotons, thriftier accelerators, traps that lose fewer particles to the slow leaks of reality, materials that soak up gamma light without growing brittle, field coils that keep their promise for decades, algorithms that shepherd a charged cloud as tenderly as a shepherd keeps a flock. Each improvement is small. Together they turn fiction into engineering notes, then into drawings someone can build. It helps to remember that every great voyage began with a small, exact tool, a polished lens, a reliable clock, a map drawn to scale. Antimatter propulsion, if it comes, will arrive the same way, not as a cinematic leap, but as a string of modest victories that never lost sight of caution. We do not need to promise tomorrow to honor the beauty of the idea today. Starlight has a way of touching the skin like cool silk, and somewhere inside that softness lives a simple idea: light can push. A photon is weightless, yet it carries momentum. When it meets a mirror, it nudges. In the hush of space, where there's no air to grip and no friction to steal energy, that tiny tap can add up. A sail wide and reflective can sip those taps all day and all night, and a craft can slide forward the way a leaf rides a slow current, gathering speed not by violence but by patience. A solar sail is mostly emptiness, a film so thin it shivers like frost, and yet spreads to the width of fields. It carries no propellant and keeps no tank. The sun is its engine, the sail its conversation with light. Photons arrive, bounce, and leave a fraction of themselves behind as motion. At first, the acceleration is scarcely more than a thought, a fraction of a millimeter each second squared, but minutes become hours, and hours become months, and the quiet push grows into a respectable pace. In a place where nothing drags, persistence is power. The roots of this thought are old. Long before rockets learned to roar, people imagined space as an ocean and dreamed of catching its wind. Through the 20th century, a handful of small tests showed that sunlight could nudge hardware. In 2010, a Japanese sail unfurled in the inner solar system like a silver kite and rode sunlight successfully. Later, a citizen-backed craft called Lightsail glimmered above Earth, its polyester mirror opening into a bright square that proved orbit could be changed by shine alone. Each success felt modest and miraculous at once, a spacecraft that moves by being polite to light. Steering such a craft is more art than muscle. The sail tilts a little to one side or the other, catching photons at angles that change the path tacking, just as sailors do on water. Tiny attitude actuators, shifting masses, or reflective vanes trim the craft's posture in the stream. A degree becomes a course correction, and over long arcs those fine adjustments add up to flybys, rendezvous, even departures from the sun's hold. Guidance becomes a slow choreography between geometry and patience. Laser sailing takes the same principle and turns the sun into only one option among many. If light is the wind, why not make our own gale? Focused beams, phased together from an array of ground or orbital lasers, can pour momentum onto a small, brilliant sail and push it far harder than sunlight can. Picture a wafer-scale probe grams in mass, hitched to a mirror only meters wide, its edges tuned to shed heat, and its face polished to a whisper. A few minutes inside a disciplined beam, and it could leave the neighborhood at a significant fraction of light speed, then coast for years toward the nearest suns. The promise is bright, and so are the hurdles. A sail must be light yet strong, reflective yet tolerant of heat. A crease can become a weakness, and a pinhole can grow. Deployment is a ceremony. Blades and booms unroll without a hand to smooth them. Static clings. Micrometeoroids write their small notes across the film. For lasers, the challenge is precision at a scale that humbles metaphors. A beam must stay married to a moving target across hundreds or thousands of kilometers, through air that shimmers, through optics that must not blink, through control loops that must predict as much as they react. And then there's aim. The sail is not just a mirror. It's a wing in a very thin wind. As temperature changes and radiation whispers, the film can wrinkle. As the beam pushes, the sail can wobble. Engineers imagine gimbals and adaptive optics, edge actuators that tweak curvature in real time, and star trackers that can read the sky even when drenched in light. The craft itself may help spinning a little to even out stress, or carrying a dark patch at its center that aligns the beam like an iris. The beauty of light propulsion is its quiet economy. There is no exhaust to blacken the void, no tank to empty, no burn to time against a ticking clock. The energy comes from a star or from clean grids at home. The craft accelerates for as long as the light is kind and the sail stays true. That gentleness changes the shape of missions. Instead of sprinting and coasting with long, helpless drifts, a sail can keep leaning into its push, then turn and lean the other way to slow down, entering orbits gracefully rather than slamming on brakes made of fuel. Physics keeps the picture clear. Each photon carries only a tiny kick, so area matters, reflectivity matters, mass matters. 100-meter sail can over months draw a craft into tens of kilometers per second. Over years, the numbers grow. Laser sails, if the beam is bright enough and the sail brave enough, could leap straight beyond the planets, but the structure must survive a bath of energy that would blister most materials. Heat must leave quickly. The sail must not curl or tear. The probe must not melt the very mirror that carries it. Navigation becomes a kind of listening. Solar sails hear the sun best when they are close. Farther out, the whisper weakens. Laser fleets, if we build them, would hand off a probe from array to array, like lighthouse keepers, exchanging a torch. Along the way, celestial mechanics lends a hand. A sail can steal momentum at a flyby by changing angles at the right time, or climb upwind from the sun by patiently tacking. What sounds like magic is only patient geometry under steady light. These craft invite us to think of exploration as something elegant. No thunder, only a gentle rise in speed. No plume, only a sheen. They ask us to invest not in bigger tanks, but in better mirrors, smarter control, sturdier films, and beams that can hold a shape across horizons. The same advances feed other needs. More efficient station keeping for satellites, silent repositioning without propellant, deep space power beamed to small instruments asleep at the edge of sunlight. There are risks that must be met with care. A sail hundreds of meters wide is a vulnerable thing. Micrometeoroids can stipple it. Radiation can embrittle it. A misjudged maneuver can fold a corner that never unfolds again. A laser beam that powerful must be fenced with law and good sense, kept clear of eyes and atmospheres that shouldn't feel its heat. Atmosphere itself writhes, so arrays might climb to high-altitude sites or orbiting platforms, where optics and governance both grow simpler. Still, the vision holds steady because it matches the place we mean to travel. Space is a patient sea. It rewards those who can accept a small push for a long time and who can trim a sail rather than force a turn. It lets tiny craft go very fast if they can endure long stretches without attention and can phone home with whispers that carry meaning. Gram-scale probes could precede us to nearby stars, flashing back compressed pictures and spectra like postcards from a new coast. Larger sails, draped from boom to boom, could wander the Kuiper Belt, sample comet tails, or park above polar regions to watch Earth's auroras from a seat of quiet light. Hybrid possibilities bloom as materials learn new tricks. A craft might ride sunlight inward, then catch a laser outbound, first a long, easy climb, then a precise, powerful push. Magnetic sails could unfurl near a destination to break against a star's wind, saving the sail for science and shade. Miniature mirrors at the edges could flex to trim focus. Tiny cold gas puffs might handle emergencies without meaningfully altering mass. Autonomy would grow gentle and wise, tuned for years of small decisions that add up to safety. In the soft arithmetic of sleep, there is something reassuring about an engine you cannot hear. The universe gives us photons everywhere. The craft only has to be polite enough to use them. And the symbolism is warm, a way of moving that aligns with what already is, rather than defying it. A voyage powered by the same light that paints our mornings and cools our evenings. If you imagine such a ship tonight, let it be a bright square against black, unfolding like a sigh. Let it turn its face to the sun and feel the faintest touch, then collect that touch again and again until touch becomes motion and motion becomes travel. Far away, perhaps years from now, another sail might catch a directed gleam from arrays that hum in the thin air of high deserts or the steady dark of orbit. The beam would find the mirror, and the mirror would answer not with noise, but with a quiet, accelerating yes. Step by step, experiment by experiment, we learn how to make that yes reliable. Films grow stronger and smoother, coatings reflect more and heat less. Guidance learns to hold a line without fuss. A single photon is a whisper, trillions of them are a current. And on that current, across the deep and patient night, a sail can carry us farther than fire ever could, softly, steadily, with room enough in the silence for wonder. Starlight close to home has a different kind of hush. A handful of suns sit just beyond our heliosphere, steady lanterns on the dark road, and they whisper a promise. If we can learn to travel with patience, the first crossings won't be to mythic distances, but to neighbors whose light already grazes our nights. Closest of all is a family Alpha Centauri, 3 stars bound in a long, quiet waltz. Alpha Centauri A shines with a warmth very much like our own sun. B is a touch smaller and cooler, circling its sibling in a dance measured in decades. Far out, dim and red, Proxima keeps a slower watch. Proxima Centauri is the nearest star we know, about 4.2 light-years away. Light itself needs a little over 4 years to make that trip. Any ship we build will need far longer, which is why closeness in space can still feel like distance in the bones. Proxima matters for another reason. It hosts at least one small world. Proxima B circles within the balmy band where liquid water could linger, not because it sits far from its faint star, but because the star burns softly. The orbit is tight days rather than months. and tides likely lock one hemisphere in endless daylight, while the other sleeps in night without dawn. Between them lies a thin line, a terminator ring, where twilight never ends and temperatures may soften. It's only a sketch in our instruments for now, but it gives the mind a place to rest, a planet near enough to imagine, strange enough to study. A breath farther stands Barnard's star, roughly 6 light-years away, older than our sun and hurrying across the sky with a proper motion you can measure over a human lifetime. Evidence has hinted at a super-Earth in a chilly orbit. They're massive compared to Earth, circling every 2/3 of a year, bathed in a thin winter light. Whether that world is ice above and rock below, whether heat pools deep under a shell the way it may on Europa or Enceladus, remains a question written faintly in the star's wobble. Nearby doesn't have to mean friendly. It can simply mean reachable and worthy of a quiet hello. Other neighbors fill out the map like small fires in a campground. Wolf, 359, at about 7.8 light-years, is another red dwarf, so faint you need glass to greet it. Lalande 21185 glows at around 8.3 light-years, a patient ember long watched for planets. Sirius, bright enough to catch the eye in winter, sits about 8.6 light-years away and keeps a dense white dwarf companion, Sirius B, an old star's bright, compact memory. Not all of these systems are likely harbors for gentle weather, but together they teach us the variety of suns in our neighborhood and help us choose where to aim our first true questions. The distances in this little atlas are both kind and stern. Our fastest probes skim at tens of kilometers per second. Even so, the nearest stars would take tens of thousands of years to reach by chemical means. The arithmetic isn't cruel, it's honest. It tells us why the conversation turns to sails of light, to fusion gardens, to patient nuclear hearts, engines that fit the size of the room. It also shapes our sense of mission design, more endurance than impulse, more shielding than swagger, more autonomy than conversation. Because even signals stroll at light speed, and 4 years is a long walk for a message. To read these systems from afar, we lean on light as both messenger and map. Radial velocity instruments catch the tiny sway in a star's spectrum as planets pull it gently to and fro. Transit surveys watch for a brief dimming when a planet crosses the stellar face, like a bird's shadow passing over a field. Some telescopes take the harder path of direct imaging, masking starlight to reveal faint companions beside the blaze. Add careful timing and the sensitive nose of spectroscopy, and we begin to read atmospheres, hints of water vapor, carbon dioxide, methane. Someday, perhaps, a pair of gases out of balance in a way that only life tends to keep. The stars themselves matter as much as their company. Red dwarfs like Proxima and Barnard's are frugal and long-lived, burning slowly for trillions of years, time enough for experiments in biology to run long. But they can startle too. Frequent flares that lash close-in planets with hard radiation, winds that may peel at atmospheres unless magnetic fields stand guard. Sun-like stars feel familiar, a little kinder to surface oceans, though fewer of them sit within arm's reach. Every choice is a trade. Distance against habitability, stability against spark, what we can reach against what might welcome us when we arrive. Concept missions turn the map into a plan. Tiny probes, light sail bright, could ride a disciplined laser shove to 1/5 of light speed, then coast the rest of the way to Alpha Centauri in a few decades. They would be cameras and spectrometers on chips, not cabins and kitchens, a quick look rather than a settlement. Their postcards would be precious, crescents lit by another sun, spectra that whisper of clouds or bare rock, the silhouette of a moon. Those first glimpses would refine our targets and our questions. They would not end the longing, only make it more precise. The practicalities arrive like steady surf. High speed turns dust into danger. A fast ship needs a bow that turns pebbles into powder, and fields that sweep charged grit aside. Radiation is patient. Shielding must be, too. For any craft that carries breath, closed-loop life support becomes a little world. Water that returns, air that is gardened, heat that finds its way outward along radiators glowing like low dusk. Autonomy is not a luxury but a temperament. Navigators that can choose without asking. Doctors that can treat without waiting for advice that's years away. Meanwhile, our telescopes keep learning to hear fainter songs. Ground-based mirrors with exquisite spectrographs measure jitters smaller than a walking pace. Orbiting observatories tease out the fingerprints of molecules in a single pixel of starlight. From these whispers, we build weather reports for worlds we cannot touch, tidal locking and twilight rings, greenhouse blankets and hazes, thin snows of radiation, and the shelter of magnetic fields. We learn what habitable might mean when a day never ends, or when warmth comes from within. The meaning of those nearby stars isn't just geographic. They are waypoints for the mind proof that the universe offers reachable questions. A crossing to Proxima, even by a robotic mote, would be a hinge in our story, joining the age of looking with the age of going. And tucked beneath the engineering is a softer note, the thought that life might not be a local habit, but a common courtesy in the galaxy. If we were to find a breath's trace in an alien sky, oxygen out of balance, methane that cannot sit still, it would turn our small blue home from exception to example. Reaching outward asks us to tend inward as well. The technologies that make long voyages gentle, clean power, careful recycling, patient autonomy belong at home first. A civilization that hopes to garden a ship for decades should practice on a planet it already loves. In that way, Alpha Centauri and Barnard's Star become more than destinations. They become reasons to be better at living where we are, so that when we do go, we arrive kindly. Nearby suns serve as both mirrors and windows. In their light, we read pieces of our own story, how stars are born, age, and wander, and we watch other stories unfold with different tempos and endings. Red dwarfs, slow burning, and long-lived, sketch a future far beyond the sun's span, a patient cosmos measured in trillions of years. Sun-like stars, bright and brief by comparison, let us hold our own system at arm's length and notice what is ordinary and what is rare. Composition, age, and motion weave together like threads, revealing where the Milky Way has been and where its planets prefer to gather. Reaching for those threads is bigger than any one lab or flag. Telescopes on calm mountaintops, radio arrays combing the dark, orbiting observatories tuned to the faintest colors, these are shared instruments. Space agencies, universities, small teams with hand-built sensors, and private ventures strum the same chord, cooperate or go dim. When mirrors in Chile link their glass to spectra from a space telescope, and when a laser sail concept borrows a material trick from a sail once flown in low Earth orbit, you can feel a map being drawn by many hands. The question under all this looking is tender and ancient. Where could we live? Earth is a careful balance, liquid water, a sky that filters and warms, a magnetic field that keeps the harshest wind at bay, a climate that wobbles without falling. We call a star's Goldilocks band the habitable zone. But temperature alone is just the first kindness. Rock or ice beneath, air thick or thin, chemistry generous or stingy. A star steady or stormy, each adds or subtracts from the chance that a world can cradle breath. In recent decades, the sky has answered with a flood of worlds. Transit watchers notice tiny dimmings as planets slide across stellar faces. Precision spectrographs feel the tug of small companions in a star's heartbeat. Sometimes, with clever optics, a faint dot is pried from a glare and seen directly. Super-Earths, mini-Neptunes, hot Jupiters do their rounds. A few small rocky spheres turn at temperate distances. Most are too far or too harsh for us. Each discovery sharpens our senses, refines our questions, and moves, habitable, from a slogan toward a spectrum. Among the nearby lanterns, Alpha Centauri draws the eye. Two sun-like stars share a long ellipse, while Proxima, small, cool, and close to us, keeps to the outskirts. Proxima b, a rocky planet in the gentle band by that dim ember, sits only a handful of light years away. Yet nearness is not permission. Red dwarfs flare. Their radiation can sandpaper atmospheres unless magnetic shields hold. A world tidally locked may roast on one side and freeze on the other, with a ring of permanent dusk between an eternal shoreline where mildness might survive. Possible, not promised. Inviting, not safe. Barnard's star, older and restless across our sky, likely hosts a super-Earth in chill twilight. If its crust hides oceans under ice, warmth might seep from within the way it does on icy moons closer to home. We cannot see its seas, if any, yet. What we have are rhythms in starlight and models that breathe on a screen, teaching us what to try next, which filters to craft, which wavelengths to chase when a telescope inhales a faraway sunset. To judge a world gently, we must taste its air. Starlight, stretched through a thin atmosphere, picks up fingerprints, water vapor, carbon dioxide, methane, perhaps oxygen, paired with something that should have eaten it long ago. Chemistry out of balance is a rumor of life, but cautions abound. Venus glows with clouds, yet punishes with heat and pressure. Mars wears riverbeds and keeps its water locked away and its air thin. The lesson is humility. The right distance is not enough. The right orchestra of conditions must play together for a very long time. The pull to go is not only a matter of safety, but safety does speak. A single world carries all our weather, all our food, all our futures. Diversifying where life can be is a kind of kindness to tomorrow. Yet curiosity has its own gravity. We want to see how many ways a planet can be a home, how many recipes biology can write when given new kitchens. Looking outward expands the room in which our questions can breathe. Distance keeps us honest. Even the closest stars are far beyond the reach of chemical fire. So engineers draw engines that match the size of the map. Nuclear hearts that hum for years, fusion gardens that turn pellets into push, wafer-thin sails that lean into sunlight or ride a disciplined laser. Each promise carries an inventory heat to shed, dust to survive, radiation to tame, guidance that must think alone for long stretches, and each success at small scale becomes a rung on a ladder we will climb slowly. A destination matters as much as a vehicle. Without a world that can welcome water and keep an easy sky, a crossing becomes a parable rather than a settlement. Terraforming sits on distant pages. Nearer pages ask us to find Earth-like places first, or at least worlds that can meet us halfway. Soil that can learn to carry crops, rocks that can be kind to roots, ice that can be freed without breaking the climate that would hold it. These are the details that turn arrival into living. Even when a world calls to us, time does its own arithmetic. Stars brighten and quiet over eons. Flares rise and fade. Habitable bands drift. Red dwarfs are generous with years, but temperamental with storms. Sun-like stars are steadier, but their candles burn shorter. Choosing when to go is part astronomy, part philosophy, part patience. A window that opens and may not stay open forever. If people ride the first long ships, life aboard will be a small civilization in a careful shell. Gardens will recycle breath. Schools will teach constellations that shine behind and ahead. Laws will travel with compassion for those who must keep them far from home. Culture will need rituals that make decades feel like a life, not a delay. Governance will have to be quiet and sturdy, the way a keel is, rarely seen, always necessary. Back on Earth, instruments keep learning to read finer whispers. New surveys scan bright nearby stars for dim crossings. Larger mirrors, cooled in space, split thin beams to weigh atmospheres by color. Modest crafts ride sunlight to test deployments we'll need later. While algorithmic caretakers learn to steer without hands, the work feels like knitting. Loop by loop, a fabric appears where there was only thread. Hope and caution sit side by side. The sky is rich, more worlds than grains of beach sand, and yet the set that suits us will be small. That is not a reason to rush. It is a reason to get the basics exactly right. Power that is clean and patient, habitats that heal themselves, engines that respect the places they pass. The same skills that will keep a starship alive for decades can keep a planet healthy for centuries. Exploration and stewardship are the same habit, played in different keys. So the nearby stars remain lanterns and lessons. They show us how galaxies build and age, how planets choose their orbits and their heirs, how life might learn other alphabets than ours. They also teach a gentler truth, that going farther begins with seeing clearly, and that seeing clearly begins with stillness. In that stillness, under a sky we share, we trace the faint signatures of future harbors, and we practice, here and now, the slow, kind crafts that will let us reach them, and, when we do, arrive softly. Imagine shaping homes from starlight and patience, rather than waiting for a perfect second Earth. The farther we look, the clearer the lesson. Nearby suns are close only in poetry, and truly gentle planets are rare. 4 light-years to Proxima is a short sentence for light and a very long road for us. So the mind turns to worlds of our own making. Rooms in the sky tuned for breath and sleep. Gardens that grow under careful suns. Gravity spun from motion and kindness. Rotating habitats sketch the first lines. Cylinders and rings that turn to press feet toward a floor. Day and night, painted by shutters that sip or shade the Sunday. Inside, fields and orchards, reservoirs and streams, towns strung along curved horizons where dawn is a moving stripe. Beyond them, domes and caverns on moons and asteroids, their walls layered with rock and water to hush radiation and the ping of dust. Temperature, pressure, light, and wind arranged like music, never harsh, always livable. Protection is the quiet work. Earth's magnetic cloak stays behind. Out here, we build our own. Water jackets and regolith berms soak up cosmic rays. Superconducting coils may one day bend high-energy particles aside. Windows face indirect mirrors. Storms are seen, not felt. In such rooms, health is design. Cycles of light that honor circadian rhythm, green places wide enough for wandering thoughts, air that smells faintly of basil after rain. Supply follows the nearest stone. Metal from asteroids becomes beams and trusses. Silicates melt into glass. Lunar regolith bakes into brick. Ice from shadowed craters unknots into water and air. Sunlight, concentrated by gentle optics, runs farms and workshops. Waste is not a word here. Loops close until every molecule has a path home, water breathed and returned to the tap, carbon harvested from exhale and folded back into leaves. Habitats invite a new meaning of world. A place can be purpose-built, a research valley where telescopes rest above a quiet plain, an arts quay with low-gravity amphitheaters, a school spun to Mars-like gravity for gradual adaptation, a convalescent grove where bones heal faster under 1G. Weather is a story we write, mornings that begin in gold, afternoons with a brief, soft rain. Ecosystems become modules that click together: forest, wetland, orchard, meadow, each tuned to support the others. Scale is generous. One ring might hold thousands. A cluster linked by light rails could host a city. A necklace of clusters could orbit in gentle lanes, migrating with need. Unlike a planet, a habitat grows by addition. If population swells, add a valley. If a design proves unwise, revise it without moving mountains. Civilization spreads as constellations of craft, rather than a single footprint, each node resilient, each sharing power, water, and news. Culture would change in kind ways. Rituals would grow around sail deployments and harvest days, around the long look when the Milky Way is a ribbon through the window. Children might learn 3 gravities: play in low G, study in lunar G, sleep in earth G, so muscles, bones, and hearts keep the rhythms they need. Architecture would wear biophilia openly: cedar paths, moss walls, birdsong recorded and remixed with the hush of fans. Governance would prefer the sturdy and the simple, because air and water leave no room for drama. Accountability would be as routine as maintenance. Such rooms in space double as way stations, repair docks for deep space ships, greenhouses that raise seed and rootstock bound for colder orbits, laboratories where engines learn to run for years without drama. When departures grow ambitious, a probe to a nearby sun, a crude loop to the outer ice, launching from a quiet cylinder, is kinder than climbing from a deep gravity well. In time, that network becomes a lattice that supports the longer reach. The know-how is assembling now: robotics that weld and print in vacuum, inflatable volumes that lock into rigid frames, AI that watches valves and bearings with a medic's patience, 3D printers that turn asteroid dust into struts and soil, power from thin, efficient films, heat moved through capillaries like sap. None of this is magic. All of it is practice. Each small mission, an algae loop that never crashes, a garden that feeds more than it costs, a radiator that never clogs, is a bead on a string that, together with the rest, becomes capability. Scarcity bends when space becomes part of the pantry. New acreage without cutting forests, fresh energy without smoke. Farms under glass can trial crops for dry lands on Earth. Waste systems tuned for zero loss can return home as clean rivers and quieter cities. The best test beds for living well off-planet are also tools for living better on-planet. Exploration and stewardship stop arguing and start harmonizing. Even in the gentlest rooms, time remains the largest distance. The span between suns is measured not just in kilometers, but in summers. If we mean to cross, 2 biological tricks step forward: slowing and pausing. Suspended animation cools the body into a lower gear. Metabolism eased, cells asking for less, buying doctors hours in emergency rooms, and perhaps, one day, buying travelers months. Cryogenic sleep imagines a deeper quiet, temperatures near liquid nitrogen, chemistry slowed to nearly nothing, guarded by cryoprotectants and vitrification so ice cannot cut the cells. Nature nods along. Tardigrades dry to dust and wake years later. Certain frogs freeze in winter and remember spring. Medicine echoes them in small, careful ways. Therapeutic hypothermia after cardiac arrest. Organs shipped on ice so that another life can begin. The frontier lies in scaling from parts to wholes, preserving a person entire, then warming them as evenly as dawn. It asks for molecule-wise guardians, nanoscopic repairers, perhaps to watch membranes and proteins while the clock is quiet. Ethics travel with the technique. A sleeper has rights. Who speaks for them while they rest? How do we promise revival into safety, into community, into a future that still wants them? Consent must be as durable as the capsule. Governance must be as steady as the pump that keeps the cold true. Every technical diagram needs a margin for dignity. The engines of such voyages would also have to keep their own counsel. Autonomy would tend the ship like a monastery, monitoring, adjusting, repairing, all in the long night between stars. Shielding would turn dust into light. Fields would brush cosmic rays aside. Power would be constant and calm, with redundancies nested like dolls. If sleep is to be kind, everything around it must be kinder. None of this is promised soon, but none of it is beyond learning. We already recycle air on stations, grow lettuce above Earth, 3D print metals in microgravity, and practice the subtle craft of keeping people well in closed rooms for months. We already design habitats that heal mood and sleep with light and green. We already stitch coalitions that share data from the quietest telescopes. The work feels like knitting loop by loop until a sweater appears, and the sweater is a room, and the room is a valley, and the valley is a small world. On a clear night, it's easy to picture an O'Neill cylinder turning like a slow clock, river curving up the walls, children running along a path that never quite reaches the horizon. It's easy to picture a maintenance crew, 2 humans and 3 robots, smoothing a new film across a mirror that will pour sunlight into gardens all winter. Somewhere farther out, a small craft carries sleepers toward a dim red ember, its bow glowing softly as it meets the thin rain of interstellar dust, all of it quiet, all of it plausible in the language of physics. If the stars are patient, we can be, too. We do not have to find a perfect world before we learn to live well beyond one. We can build rooms that treat breath as precious, craft voyages that treat time as elastic, and practice a gentler strength, one that carries life forward without bruising the dark.